Welcome to Simplifying Radicals, a review. Let's get started. Take a second to write the square root of each number on your paper. If you need a calculator, you're welcome to use one. The square root of 1 would just be 1. Square root of 4 is 2. Square root of 9. Square root of 16. Square root of 25 is 5. Square root of 36 is 6. And you can see that there's a pattern here in your table. And yours keeps going, so you can keep writing yours all the way up. Now, if you were supposed to find the square root of 60, we would know that it's somewhere between 7 and 8. And if you can look at that up here, because the square root of 49 is 7, the square root of 64 is 8. 60, the square root of 60 is somewhere in here, so it's somewhere between 7 and 8. The same thing if we needed to find the square root of 19. We can estimate, because the square root of 16 is 4, square root of 25 is 5, and 19 is somewhere in between 16 and 25. So the square root of 19 must be somewhere in between 4 and 5. So now that you know how to estimate it, what we need to do is find a very simplified version of this square root instead of just estimating it. Now, prime factorization is a good way to do this. You've got to think of two numbers that multiply to 20. The first ones that come to my head are 4 and 5. Then you can look and see 5 doesn't go any further. 4, you can do 2 and 2. So that's the same thing if we're doing the square root of 20, which is number 7 on your paper. Square root of 20, the only thing is now we have a radical. We'll turn into the square root of 4 times the square root of 5. Just like over here on this factorization tree, except we just have a radical. Now the square root of 4 is 2. The square root of 5 doesn't go any further. You can't simplify it anymore, so it just stays as is. So the square root of 20 is going to be somewhere in between 4 and 5, right? The square root of 16 and the square root of 25. And the official way we want to write it now is 2 square root of 5. And if you check the square root of 20 on your calculator, you'd see it's around 4.7. And if you were to put 2 square root of 5 in your calculator, you'd also see that it was around 4.7. So let's practice simplifying radicals. This is number 8 on your paper, square root of 60. You want to think of two numbers that will multiply to 60. And one of them you need to be able to take the square root of. So I split these into 4 and 15. I can take the square root of 4, that's 2. You can't take the square root of 15, and you can't go any further with that. So it's 2 square root 15. This is number 11 on your paper over here, square root of negative 45. The reason we're doing this example is because I want you to remember, if you've got a negative, don't forget that this is from Unit 3, that you've got to take that negative 1 out. We can't take the square root of a negative number unless you use an I. Remember, I is the square root of negative 1. So get rid of this negative first, then start simplifying like we did over here. So the square root of 45 I'm going to turn into square root of 9 times the square root of 5, because 9 times 5 is 45. And I can take the square root of 9, that's 3, and the square root of 5 stays. And then the square root of negative 1, remember we said is I. So it comes down here. And there you go. Okay, if you want to see some more examples, this is number 13 on your note sheet, and this is number 16. And remember, we want to split up each number and variable. So we still have the square root of 32, the square root of a to the 6, and the square root of b to the 8. Now the square root of 32, we're going to have to simplify like we just did earlier in the video. So we can think of two numbers that multiply to 32, and I'm going to do 16 and 2. And the square root of 16 is just 4. This doesn't go down anymore, so we've got 4 square root 2. And now we can come back over here and work with these variables. a to the 6th, square root of a to the 6th, remember we turn into rational form, which is a 6 over 2, and that becomes a cubed. Over here, again, turn it into rational form. That's b 8 divided by 2, and that becomes b to the 4th. So this right here is your answer. And it helps if you put all of the variables together and leave the one that was in a square root to the side. But it's the same thing either way. Now over here, this -9 is on the outside, so you're just going to bring him down all the way to the end. You're not really going to mess with him. So just worry about the square root of 8x. The square root of 8 and the square root of x, all we did was break that up. And then here we're just still going to have the -9. The square root of 8 we need to simplify because you can't take the square root of 8. So I'm going to break that up into 4 and 2. 4 times 2 is 8. Square root of 4 is 2, and then we bring down the square root of 2. So we're done with this right here. We've taken square root of 8 to 2 square root 2. Now let's go back and deal with the square root of x. Remember, it can't leave this radical because it doesn't, if you try to divide it, it would become x 1 over 2. So since it won't do anything and you can't reduce it any further, then all you do is bring the square root of x down. And then we still have this -9 that's down here, still multiplied by that. So now we just need to put things together. -9 times 2, we've got -18. And then we have the square root of 2 and the square root of x, and they can go together under the radical. There you go. Now be sure to try the rest of the examples on your own, 7 through 16, and we'll check them together in class. And that's all. Thanks for watching. See you soon.